Hey, this is Mr. Mola for lesson 2.6, Solving Absolute Value Inequalities. This is very similar to in chapter 1 where we solved absolute value equations. Now it's just an inequality. Okay, so first things first, our first step is making sure the absolute value is by itself. So if I look at number 1 here, it is by itself. Absolute value of y plus 2 is the only thing on the left side. So that's our step 1, make sure the absolute value equation is by itself. Then I can make my two equations. So 1, nothing's going to change. Y plus 2 is less than 8. And then for the second one, though, we're going to change two things now. I'm going to flip my sign from a less than sign to a greater than sign. I'm going to change my positive 8 to a negative 8. Okay? Otherwise, the steps are still the same. It's a plus 2, so I'm going to subtract 2. 2 minus 2 cancels. So I get 8 minus 2 is 6, so y is less than 6. Same thing over here, it's a plus 2, so I minus 2. 2 minus 2 cancels. Negative 8 minus 2 is negative 10. So our two answers for this is y has to be less than 6. So we'll say 6 is over here. Open circle because it's a less than, not a less than or equal to. And numbers less than 6 go to the left, like 5, 4, 3, 2, 1. And then over here we got a negative 10. Open circle again because it's a greater than sign, not a greater than or equal to. And numbers greater than negative 10 go to the right, like negative 9, negative 8, negative 7, all those numbers there. So that would be our one for number 1. All right, number 2, same thing. Make sure our absolute value is by itself. It is, we're good. So I'm going to write out my two equations. Let's do black and blue this time. All right, so Q divided by 3 is greater than 2. And then my other equation, Q divided by 3, flip my sign, is less than, flip my number from positive 2 to negative 2. And we're going to do the math. So that's a Q divided by 3. So I'm going to multiply both sides by 3. 2 times 3 is 6. So I get Q is greater than 6. Over here, same thing, multiply by 3, multiply by 3. So I get Q is less than negative 6. Okay, so it needs to be greater than 6. So I'm going to put an open circle here at 6, and numbers greater than 6 are like 7, 8, 9. So going to the right, and I'm going to put an open circle here at negative 6, and it's less than negative 6, so numbers like negative 7, negative 8, negative 9, negative 10. All right. So those are going to be the ones that we're going to be, that we like those because the absolute value is already by themselves right there on the left side. All right, let's switch to one where we have a one step beforehand, like number 5. So kind of a medium problem here. I have a minus 4 outside of my absolute value bars. So I'm going to get rid of that minus 4 first before I write my two equations. So I'm going to add 4 to both sides. So now I'm left with absolute value of 3 plus r is less than 0 plus 4 is 4. Now my absolute value bars are by themselves, so now I can write my two equations. So I'm going to write 3 plus r is less than 4, and 3 plus r, flip my sign, is greater than negative 4. Okay, and we're going to do the same math. It's a positive 3, so I'm going to subtract 3. So 4 minus 3 is 1, so I have r is less than 1. Same thing here. I'm going to subtract 3. Negative 4 plus 3 plus a negative 3 is a negative 7. So I have r is less than 1, and r is greater than negative 7. So open circle at 1. Numbers less than 1 are like 0, negative 1, negative 2, so going that way. And over here I have a negative 7, again with an open circle, because it's not equal to, and it's going to the right, like numbers like negative 6, negative 5, negative 4. Okay, let's go back up here and look at number 3, because number 3 has two things on the outside of my absolute value bars. So there's my absolute value, 2a plus 5. I got a plus 10 around here, and I have a times 3. So I need to get rid of my plus 10 first. So now I have 3 has the absolute value of 2a plus 5 is less than or equal to 37 minus 10 is 27. And then I got a 3 times that, so I'm going to divide both sides by 3. So now I have the absolute value of 2a plus 5 is less than or equal to 27 divided by 3 is 9. Now my absolute value is by myself. Now I can write my two equations. Erase this so I have some room. So I have 2a plus 5 is less than or equal to 9, so nothing changes. And then I got 2a plus 5, flip my sign, is greater than or equal to, change my 9 to a negative 9. Same steps, it's a plus 5, so I subtract 5. So I got 2a is less than or equal to 4. Divide by 2, divide by 2. A is less than or equal to 2. Same thing with the negative one, it's a plus 5, so I'm going to subtract 5. Except now I get negative 14. And divide by 2, divide by 2. A is greater than or equal to negative 7. Graphing doesn't change for these, so I have a number like 2 here. I'm going to fill in my circle because it's an equal to. And numbers less than 2 go to the left, like 1, 0. And then for the bottom one here, the blue one, I have 7. And again, a filled in circle because it's equal to. And numbers greater than negative 7, like negative 6, negative 5, negative 4, go to the right. Okay. Let's look at some of these other tricky ones here. So it doesn't change the problem, but now you'll see we got some negatives. Okay, remember from last time, if we have a negative, that means we're either looking at a no solution most of the time for those. There wasn't really an all solutions on equations, but now with these, there will be the option for a no solution or a many solution. And really, kind of the same thing. We need to make sure the absolute value bars are by themselves. So both on 6 and 7, the absolute value bars are by themselves. What we're really going to pay attention to after the absolute value bars are by themselves is the sign. Okay? And this is kind of just the rule here. So make sure, again, I'm going to say it again. I've said it probably 10 times in this video. Make sure you get the absolute value bars by themselves first. Okay? Then, if you see that it equals a negative, or is less than or greater than a negative, that's when we know we're either going to have a no solution or a many solution. And the reason for this is, no matter what goes in this box here, it's going to have to be bigger than a negative 4. Even if you pick like 0, 0 plus 12 is 12. The absolute value of 12 has to be bigger than negative 4. There's no way you're ever going to get an answer where the absolute value is not bigger than negative 4. So if you ever have a greater than sign or a greater than or equal to sign, and then there's a negative number, so you have absolute value bars, numbers on the inside, right? And you have a greater than or equal to sign, and it's greater than a negative number, it is always all real numbers, infinitely many solutions, whichever you want to use. Okay, all real numbers, infinitely many solution. And again, the reason for that is it has to be bigger than a negative number. There's no way you're going to get something that's smaller than a negative number. Okay. Here is the opposite. So same thing, absolute value bars are by themselves. So now if I have the absolute value bars by themselves and it's less than or equal to a negative number, that's not possible. Okay, there's no way that you're going to be less than a negative number. No matter what you put in there, even if you put a 0, even if you put negative 1,000,000, positive 1,000,000, the absolute value of that is never going to be less than a negative number, in this case, a negative 2. Let's put negative number so we don't always think it's a negative 2. Okay, so there's no way possible that the number inside the absolute value bar is going to be less than a negative number. So in this case, we're going to have a no solution. That is not possible. Okay, so you might have some ones on the homework that they throw them in the middle. So most of the problems are going to be 1 or 2 solution answers like the ones we just did. But you might have some tricky ones like this. Remember, greater than or equal to is those all real numbers, and then the less than or equal to is going to be those no solution ones once your absolute value is by itself, and then the answer ends up being negative.